Today we have an interesting problem coming from Croatia. In this problem we have a segment AC with known length of 85. Then we have another segment ED which is parallel to AC and has a length of 18. This segment AD splits the side BC into two halves. Also, we have the segment BE, which is 21, and we know that the segment AE is at 90 degrees to segment BE, and we ask to find the length X, which is BD or CD. Well, the first thing that comes to my mind is I really want to connect point A and B, because otherwise this picture is very ugly. The next thing I see here is this AD, and this ED is parallel to AC and splits side BC into two halves. That reminds me of midlines of triangles or trapezoids. So I need to figure out what to do with that. Probably there is some use to it. The first thing we're going to do is we're going to extend the side BE until it intersects the side AC. And now if I look at triangle FBC, I indeed see that ED is a midline of this triangle. Again, it's midline because it's parallel to the side CF, and that splits the side BC into two halves. And there's an interesting property of midline of a triangle. First of all, it splits one side in half. It's also going to split the other side in half, which means that BE and EF have the same length of 21. And the next property of the midline is that it's half of the side CF, which means that CF is 36. But if CF is 36, we know AC is 85, it means that AF would be 49. Next thing, let's look at the side AE. And notice, if you look at triangle ABF, we find that AE is an altitude and also side BF bisector. And we know if we have a triangle and the same line is a bisector and the altitude, it means that we are dealing with an isosceles triangle. And that means that AF equals to AB, and that is 49. Notice if you look at the triangle ABC, we notice that we know two sides of this triangle, AB and AC, and we would like to find the third side, BC. By itself, it's not sufficient to know two sides of the triangle to find the third side. In this case, we need to know something about angles of the triangle. And that makes me think of law of cosines. So in law of cosines, to remind you, if I know two sides of a triangle, let's say A and B, and I know cosine of the angle between them, that's sufficient to find the third side of the triangle using this formula. So what we can do, we can use the triangle ABF, and I know all three sides of this triangle, to find the cosine of angle A by simply using law of cosines, by reversing it a little bit, rearranging it a little bit, to find cosine here, and then use this cosine of this angle and the sides AB and AC to find the third side BC. And that's what we're going to do. So for the small triangle ABF, we can write law of cosines, and that's what we have here. We know everything here except for the cosine. So we can use this formula to find cosine. And we can write another law of cosine for big triangle ABC. And in this expression, I know AB, I know AC, and I will get cosine from the previous expression. and that will be enough to find the side BC, and from that I can find x. Let's use this first law of cosines to find cosine of angle A. If we rearrange the terms and put the values for each of the sides, this is the expression we're going to get. And now let's look at the second law of cosines. If you plug the values for the sides, this is what we're going to get. And the next thing we're going to do, we're going to substitute this value for cosine of angle A here. And if we do, we find that BC squared equals to 66 squared. And that would mean that BC equals to 66 and x is a half of it. And that's our final answer.